Number 12, we need to make an estimate, then divide as if the dividend were a whole number. Use your estimate to place a decimal point in your answer. And that's the steps that we went over in class 2, so it's nice when the question helps us out. So the first thing we need to do is do an estimate. We've been working with two ways to estimate here. One, we could do a magnitude estimate, which are these boxes I have set up. You take your divisor and you multiply it by each of these numbers, which is times 2, times 2, and times 2. And now I always like to write it up above then. And we can start here. 2 times 100 is 200. 2 times 10 is 20. 2 times 1 is 2. And 2 times a tenth is 2/10. And then we just go through and look and see which number will fit into our dividend. And will 200 go into 6? Way too big. 20 is also too big to fit into that 6. And we know that 2 will fit, so that tells me my answer will be in the ones place. Or we could go with the more standard way to estimate. I always suggest you keep the divisor the same and you find a friendly number or a number that can be divided by 2 pretty easily. And we could go here, we could do 6, or if you want, we could even do 8 divided by 2, and that gives us of an estimate somewhere around 3 or 4. So whether you choose the magnitude estimate with the boxes or you prefer more of a standard estimating strategy, that would be fine. And just thought of another one that some kids may choose to use. If we make this a 6 and go ahead and divide it by 3, because 3 goes into 6. So again, we're still in that same ones place. Now we need to divide, just like the problem told us to. We need to ignore the decimal. So we are going to do 671 divided by 2. Now what I'll do is I will show you traditional and partial product at the same time. So first thing we need to do is, does 2 go into 6? Yes, it does. It goes in 3 times, so it's a 6. So I add in those zeros. To cover that 7 and the 1. So I need to make sure that I add my zeros to the partial quotient. Now I do my subtracting. Does 2 go into 7? Yes, it does. It goes in 3 times again. So it goes in a 6, and we said that went in 3. But wait, we need another 0 while we're working on that partial quotient part. And we subtract, and we get 11. And does 2 go into 11? Well, that gets close here. It goes in 5 times, which gives us 10 with 1 left over. Okay. Now you can see here we kind of have an issue. The issue is we have a remainder, but you don't get remainders when you're dividing decimals. So watch what I do here. Okay, I need to go back and add a 0 in, because 0 will not change. 6 and 71 hundredths is the same as 6 and 710 thousandths. So I need to put that 0 in, but when I do that, watch what I do. I'm going to use black the whole way through. I need to add zeros into my work on the inside, but I also need to make sure that I add zeros to my partial quotients. Okay, so as I move these zeros down, now I'm left with 10. And for the record, if you're using traditional, this is a lot easier to deal with if you ever have to add that 0 in. This is the one drawback of using partial quotient. And now I need to extend my work over here. So I have 10. How many 2's go into 10? It goes in 5 times. So I put a 5 here, and 5 times 2 is 10, and we are able to finish up that question. Now I know this got a little crazy here, which does happen sometimes, so we need to add up our partial quotients, and I'm going to put this 5 over here so I don't forget about it, and we need to add it up, and it looks like originally we are looking at 3,355. But wait a second, we need to come back to our estimate. And my estimate, both of them were telling me that it's going to be somewhere around 2 or 3 or 4, or my magnitude estimate said it's going to be in the ones place. So with all that being said, our decimal point goes between the threes, and we get the answer of 3 and 355 thousandths. Number 13, we need to write an equivalent problem that has a whole number divisor. All right, and then we need to solve the equivalent problem and complete the number sentence. Okay, so our divisor, I labeled them here. Our divisor is the second number. You may also like to see it like this. Some students prefer to see it that way. This is how we'll typically do the work with that question. All right, so what we need to do is we need to get this divisor, we need to make it a whole number, so we are going to hop the decimal to the right. So whenever you hop the decimal in the divisor, you need to be fair and change the dividend the same way. We hop it over one place. So our equivalent problem, what that means is they just want to know what our new problem looks like. So after we adjusted the decimals, it actually turned into a rather simple problem that you could show like this, which is 48 divided by 6. Or you could rewrite it more of a standard looking question, like they gave us to start off with, and just do 48 divided by 6 equals a question mark. So when we go in to solve this, it ends up being a nice little problem because it's just a basic fact. How many times does 6 go into 48? It goes in 8 times. And that is it for our answer. So when you get 4 and 8 tenths divided by 6 tenths, you get the answer of 8. And just to double check, in case you're wondering, how do we use that estimate, or why didn't I do an estimate? Well, to be honest, I sort of kind of forgot. I was excited to do this problem. So we could look at 4 and 8 tenths. We could make a 5 divided by, we know that 6 tenths is pretty close to 1, so we could do an estimate that gets us an answer of around 5.